She started driving at 16. I finally got my license at 18.
Does anybody have homework questions before we begin our review session?
Worry about it later.
I did want to take your attention to a Canvas link I have here. So if some of you suffer from test anxiety, I have an article posted that could be helpful. On the home page, there's a module, How to Study for a Math Class. So there's just basic ideas on how to study for a math class, which are helpful. But also journaling to improve exam scores will take you to an article that talks about journaling the few minutes before class. And if you suffer from test anxiety, I think that's a particularly helpful article. On our review today, you'll see a number of references to Mindscapes. Those can be found by going to the Wiley Plus Read Study practice link. So for example, in 2.1, I click on chapter 2. Then I go past the chapter opening to the next section for 2.1. It should say something about counting. At the very end of each section, you'll see the Mindscapes just as they're written out in the textbook. And those are the Mindscapes that I'm referring to in your review. So some of these Mindscapes that I refer to in the review are not assigned Mindscapes, and so you'll find them here. When I had to pick out what to give you for actual questions on the Wiley Plus, I couldn't give you things that were really hard, like prove the square root of 3 is rational, or rather irrational, because Wiley Plus can't check that. It would have been all you typing things in that would be long, and then I would have to print out 90 answers and check them all by hand. So sometimes your Wiley Plus might seem kind of easy, and that's why I'm limited on what questions I can pick. Anyway, Mindscapes are found here. Does anybody have any questions before we talk about the quiz?
You said that we can have like a note card.
Yes.
Can we only use one side or can we use both sides?
Both sides. So let's write that down to start us off. Oh, one more reminder before we begin reviewing. Study group meets Mondays, that's today, 5:30 to 6:30 in ES 316. If you can't make it, you can go to the tutoring website and make an appointment with a tutor. This actually tells you how to make an appointment. There's not a link there. You'll have to follow the directions. If you can't meet on campus for some reason, you can make online appointments. So first quiz is Wednesday. You can bring a 3x5 card, and yes, both sides can be filled up with your own writing. I do collect those, so be prepared to hand it in. You don't have to have your name on it. I just collect them. This is what the first page will look like of your quiz. So those of you who are taking the quiz on campus will get a sheet like this. It's called a Scantron. You maybe have used them before for standardized tests. So you'll put your name here. Also put your name here though, because some of your answers will go on here. Students who are not taking their quiz with me will just have this page. Okay, that's okay. If you're not taking your quiz with me, then you just circle your answers. Like here, what quiz do you have? You have version A. Everybody needs to get that one right so that you have the correct key correcting your quiz. Okay, 'cause there's usually several versions of quizzes in my classes. The other thing that you'll see on this first page is three different theorems or questions that will be referenced in the questions themselves. So you have Fermat's last theorem, the twin prime question, and the Goldbach question. And some of the questions on the quiz will refer you back to A, B, and C. That's what this is, A, B, and C. So the quiz covers 2.1 to 2.4, 2.6, and 2.7. Those are the sections that we've covered, besides Chapter 1, which was the introduction. The first questions, 1 through 21, are multiple choice. So those of you who are on campus will use the Scantron for those. Those of you not on campus will have to just circle the correct answer. And then questions 22 to 28 are short answer or sometimes long answer. And you just fill those in on the quiz, okay? This is the review that you can print from Canvas. I just wrote everything on there so I didn't forget to tell you. There's a couple sections we didn't get to on this review, so on the second page there's this part to 2.7 that we will be having to look at on quiz 2 because we didn't quite finish 2.7. The third page is also for quiz 2, okay? So if you printed this out like I did, then you can set this page aside and use it on quiz 2. So the rest of today we'll be reviewing. Usually I divide you up into groups, or you get divided up into groups, and then I give you each a section to look at. And after you have some time to look at that section, then we'll get together and talk about the sections as a class. Does anybody have any questions before we divide into groups? If you get done looking at your section before the other sections are done, then you should certainly go on to another section so you can practice, okay? Okay, well, let's split up and work on the different sections then. So first row you can turn around and work with the second row. I think only you can turn around and work with the person behind you. If you could put out your name placards, that would help me, please. I'll be asking everybody in your group to provide answers, not just one person, so you might want to keep that in mind as you decide how. So you two going to work together? Yeah. Okay. And then, you doing that? Or no, you have to like turn around. Okay. God, I don't think I can do it like physically.
Besides, I feel less stupid if I talk to you. Like, dude, God, there's just terrible.
I did not like the first stuff. You're good at math. You can work together.
I'm good. It's just sometimes I like.
Did anybody print it off? Can you go online and access it?
We're gonna have to go online and
So at
access
the very
it.
beginning it says general.
You want to put your phone on? We want me to hold it.
Can you? Because I gotta use mine next hour.
Yeah.
I'm not sure if I have my charger with me. Well,
I've never been this sore. Or stiff. Like
You two get section 2.2, and your group gets 2.3, and you get 2.4, and you can get 2.6 and 2.7 really quick.
I thought that was Fibonacci.
So if you're stuck, raise your hand.
Yeah,
Yeah.
Fibonacci sequence.
Yep.
Oh, I love that one. I love the Fibonacci sequence. Oh, God.
And feet.
That was easy.
2.2.
Oh, and feet?
And feet.
Oh, feet is just the base. Feet is...
Remember, it's a number that can only be
You have
divided by
2.2?
one.
Yes.
You're going to have a question about Fibonacci, with Fibonacci min. Can you do it with, say, how about 205 sticks? Then you can have that ready. If you get stuck, you can certainly ask.
So it's like the stick
What
thing.
does
We're
the
doing
prime
a sticky.
factorization of natural numbers?
So it's
Remember how to play.
oh, I do. So we have our 205. We need to find a number that's underneath it. We take 205 minus 144. What do we get?
Also, do any of you have PC code on you that you could check on? We can do that together. We can't find any PC code
Every natural number greater than 1 is either a prime number or it
205
can be
minus
expressed
144.
Yeah.
61.
61. And I take 61 plus
every natural number
minus
greater than 1.
55.
Oh, that, okay. Now I remember.
Yeah.
61 minus 55, 6.
And then 6 minus 5.
If you're stuck, raise your hand.
Natural number greater than 1 is either a prime number.
Just want to make sure. Yeah, so it should be B.
Or it can be expressed as a prime.
Make sure it's 12. 4 plus 6 plus 1.
6. The chapter 1 is 6. Is general. What? 44.
Oh, it's actually rather than natural number.
55 plus 6.
Actually, it wouldn't be 6. It's there might be one.
Yeah.
So we just need another no, we have 5. 144 plus 55 plus 5 plus 1. Is that 205? Yes. Here is it. Because that's house. That was easy. Because you just get rid
And then we have a number.
Yeah, the proof right here. So, question. This proof right here, prove that they're infinitely primes, answer to prove that they're infinitely primes. So we write this and then don't miss any steps. You missed a step in.
Let's switch this so we both go to the computer.
Yeah, that's honestly what.
We only really have to
Prove that they're
So we just
infinitely
had to
primes or
prove
no undefined proof.
that, right?
Okay, so, you want me to read out
What
it?
did you say?
Okay. Let
You gave
M
us a
any
stick.
natural number,
Yeah, you gave us a
period.
stick question.
Okay. Well, and then you have to do these also.
Yeah.
Okay.
Cool. You have a kind of a long section there.
That's fine.
True or false?
We need a prime larger than
Let's
M.
do these first. Okay, what are first combination numbers? 1.
Did we talk about how?
Is it 1, 2?
Let
Is it 1,
B,
1?
I want
1,
to know,
1, 2,
equal 2 times 3 times 4 times dot 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 times
I
that.
remember talking about
8.
Okay.
Because you just keep
Let
adding.
B equal 2 times 3 times 4 dot 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 times M.
21.
Period. Oh, sorry, plus 1.
34. Yep, we're good. 55.
Okay, and then B is bigger than M.
That's where I stopped. 1, 2, 3, 4, 5, 6, 7, 144.
That's that one.
Yep.
And if B is prime,
233.
we are done.
If we're done, should we?
377.
I would pick some of the ones that say prove.
Can we get 1, 2, 3, 4, 5,
Those are long.
8, 9, 10, 12, 13, 14. We need one more.
Okay.
233.
If B is not prime, it has a prime factorization.
That's the first one. That first one's not. Oh, no, I'm just thinking out loud. I'm good.
let P be a prime factor of B.
And I know this one is, because it goes all the way down.
And make sure everybody in your group can answer some of the questions.
Okay, yeah, because this one is right,
Yeah.
Yeah.
because it goes down.
P is not,
That bullshit. And
P is
then,
not
I don't think the first one.
2, 3, 4, comma, dot, 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 comma,
I
M.
think it is. No,
No, I don't think it is.
maybe.
Because they don't divide evenly into B.
Oh wait,
If
yeah,
this
it
were-
is. Yeah, it's right.
This would be 1 plus and then 1 over
Yeah,
whatever that
that's
is.
right, because here, look here.
That's right. Yeah.
So that's right, so we have first part is true.
Yeah.
Second
Yeah.
is also true. Third part,
What?
wait.
And then, so P is a prime locked in
And
M.
then the fourth part is true. And the fifth part is also true.
And that's the proof.
Wait,
There's no
This
math in
one?
it,
this one's not right.
Right?
It's minus.
That's,
So,
4 is false.
4 is false, the rest are true.
and the equation is
1 through 5
B
is
equals
true.
2 times 3 times 4 times
Besides 4.
plus 1.
Every natural number is with the dominant number or expression. Yeah, that's true. Because we proved that with the stick thing.
True, yes.
Right, but A, Q, the last theorem is that you cannot go any higher than that.
We'll do a different section then.
No,
Only
we
ever
Yes,
does A
she
squared
said
plus
do a
B
different
squared equals
section
C
when we're
squared, but all the
done.
other ones
we did this one already first. Oh, what is the winning discrepancy?
So A squared plus B squared plus C squared equals
So you
possible.
take how many
A cubed
sticks
plus
you
B
have,
cubed
so
plus
add
C
all
cubed.
sticks together, how many you have, and you find the Fibonacci number that's closest. And use
Okay,
the
so-
thing will be hard.
Let's go ahead and work together. If you didn't quite get through yours, then we'll work together as a class on those problems. This is, I forgot to mention, this is the 25% of your quiz, of your grade. So do make sure that you spend plenty of time practicing so that you can do well. Because I love to see everyone get off to a good start. I always feel bad if you just start off without realizing how important something is and do poorly. Okay, so let's fill this out together. What are the natural numbers? You can take turns answering, okay, or help each other out if you need to.
So, positive integers.
Go ahead, the positive integers. So the numbers that you count with are the natural numbers. What about the rational numbers? Do you know that one, Nevada?
They can be written as fractions.
Good. They can be written as fractions, and you'll see that word ratio to help you remember. And then the actual definition that you'll see on the quiz will be, can be written A over B, where A and B are integers, and B is not 0. Okay, what are the real numbers then?
All numbers on the number line, either rational or irrational.
Good. All the numbers on the number line. And what about irrational numbers? What are irrational numbers? Were you able to dig that out?
All the negative numbers.
So the irrational numbers were the numbers on the number line that were not rational. So real numbers that are not rational. How about integers? Do you have that one? That one?
Whole numbers. Yeah, like no decimals.
Good. They're whole numbers. They have no decimal part. So you'll see them listed with dot, dot, dots before and after. So dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay, thank you. That brings us to 2.1. What group had 2.1? Okay, and can you please, does one of you have the definition that had an n and an n plus 1? Okay, can one of you read that, please?
If you have n boxes and n plus 1 items to put into the boxes, one box will contain at least 2 items.
If you have n boxes and n plus 1 items to put into the boxes, one box will contain at least 2 items. Thank you. If you have n boxes and n plus 1 items to put into the boxes, one box will contain at least 2 items. And then were Mindscapes 12 and 14 examples of that where you could practice? What was Mindscape 12? Did anybody have that yet?
Yeah. It was suppose we had a room filled with 370 people. Will there be at least 2 people who have the same birthday?
Suppose we have a room with 370 people. Will there be 2 people with a shared birthday? What did you answer?
We said yes.
Yes, because there's more than 366 people. So there's not enough days of the year for everyone to have their own day. Number 14, I think, was the one with the socks, right? Okay, so you had the sock matching problem in your homework, so that was a good example for you to take a look at. You can also take a look at the cards and dice examples that we did in class. So those are on the video, and I would encourage you to take a look at those and review those. Does anybody have any questions? Okay, thank you. Didn't know I gave such a big group such a short section. All right, that brings us to 2.2. Which of you wants to tell us the Fibonacci sequence? Okay.
1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, and 610.
Thank you. And we'll put dot, 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 because that just keeps going. So we start with 1, 1, and then you add those to get 2. Then keep adding the 2 numbers before to get the next number. So you have a list here. We'll see if anybody in the class knows which one of these is not correct, and then you can tell them whether they get it right or not. So which one of these is not a way to describe phi correctly? Anybody in class remember? Yeah.
Would it be the third one down?
This one?
Yeah.
Nope, this one's okay. This is a continued fraction of 1, so this is okay to describe phi. Any others? It's been a while, hasn't it? Any other people? That's why we're reviewing. Yes?
Was it the second one from the bottom?
Yeah, this one with the minus is not phi. So all these other ones, I should have let you answer that, right? You knew that, right?
Yeah.
Okay. So all these other ones are ways to describe phi, and if you put them in your calculator, you'll get about 1.6. But that last, second to last with the minus sign, you will not get 1.6. So we have true or false. Every natural number is either a Fibonacci number or it is expressible uniquely as a sum of non-consecutive Fibonacci numbers. True or false? That's true. Okay. So did you have an example of that?
Yeah, you gave us 205 sticks.
Okay, so if you have 205, how would you write that as a sum of non-consecutive Fibonacci numbers?
It'd be 144 plus 55 plus 5 plus 1.
Let's see. So you take the 205, and you look at your Fibonacci list, and you're like, okay, 205 fits in here. The biggest Fibonacci number I can get out of that is 144. So if I take away 144, I still have to get 61. So 61 fits on the list right here, so then you can take away 55. And you still need 6 more, and that's how you get to the 5, the biggest Fibonacci you can get, Fibonacci number you can get less than 6, and you still need 1 more. So good. Okay, so suppose instead of just writing this as a sum of non-consecutive Fibonacci numbers, you were playing Fibonacci Nim and you had 205 sticks. How many sticks would you pick up if you were the first player?
Pick 1.
Okay, so we use the same process that we use to write numbers as sums of non-consecutive Fibonacci numbers. We use that same process to play Fibonacci Nim, and we mentally count the sticks in our head using Fibonacci numbers, and then use the smallest number. Okay. And that's what Mindscapes 18 to 21 gave you practice at. There's also some more examples on the video of writing numbers as sums of non-consecutive Fibonacci numbers. Does anybody have questions? Okay, thank you. That brings us to 2.3. Who had 2.3? Okay, can you please tell us the definition for a prime number? Who in your group had that?
A prime number can only be divided by 1 in itself.
Okay, so it's a natural number greater than 1 that can only be divided by 1 in itself. And when we say only be divided, we mean only be divided evenly by 1 and itself. Does someone else in your group have the prime factorization of natural numbers theorem? Yes, what would that say?
Every natural number greater than 1 is either a prime number or it can be expressed as a product of primes.
Thank you. Every natural number greater than 1 is either a prime number, or it can be expressed. Can you finish reading that to me, please?
Or it can be expressed as a product of primes.
Good. Or it can be expressed as, and I'm going to put the word unique, as a unique, because you will need that, as a unique product of prime numbers. So there's only one way to factor numbers which are not prime numbers. There's only one prime factorization. Any questions so far? So you had a long section.
Oh, yeah.
Do you have, well, this proof, we don't have time for to cover. So I encourage you to see the 2.3 video, because that is worth lots of points You want to make sure you get those points, okay? So that brings us to the last theorems there. Fermat's last theorem. So I was going to show them in the book, but I actually have them printed here on this piece of paper. So here's Fermat's last theorem. It is impossible to write a cube as a sum of two cubes, a fourth power as a sum of two fourth powers, and in general, any power beyond the second as a sum of two similar powers. So with that in mind, I will ask you if the following is possible. Is that possible, group 2.3? No, okay. So only a squared plus b squared equals c squared. We don't have a to the fifth plus b to the fifth equals c to the fifth, or any power beyond the second. Okay, that's what this is saying. A squared plus b squared equals c squared, like the Pythagorean theorem, but that's it. We're not going to get higher integer powers here like this. The other two questions are the twin prime question and the Goldbach question. So the twin prime question, are there infinitely many pairs of prime numbers that differ from one another by 2? So did your group have that? Did you come up with twin primes in your group? Did you have time to get that far?
No.
Oh, okay. Does anybody in class remember a pair of prime numbers that are 2 units apart? You have your sieve of Aristophanes to look at, or you can look higher if you want.
One.
Sure, 41 and 43, those would be good examples. So prime numbers which are 2 units apart. You just need to have 2 in your mind, so go ahead and write some down on your 3x5 card. The Goldbach question, can every positive even number greater than 2 be written as the sum of 2 primes? So let's have someone pick out a positive even number greater than 2, and then we'll write it as the sum of 2 primes. So someone in your group, give us a positive even number greater than 2.
8.
8, okay? And how would you write 8 as the sum of 2 primes? Remember, 1's not a prime number. You need prime numbers to be larger than 1.
3 plus 5.
Sure, 3 plus 5 would be one way. So you can use your own example. Just make sure you have 2 primes here and that this is a positive even number on the left. So Fermat's last theorem, that's proven. The twin primes is an open question, and so is the Goldbach an open question, meaning it's not been proven or disproven. Thank you. That brings us to 2.4. So do you have an example in 2.4 of some modular arithmetic?
Yes.
Okay, what do you have?
So for the okay, so it was 312 and then like mod 7.
So 312 is equivalent to what, mod 7?
4.
4. And how did you do that?
So we did 312 divided by 7. And then we got 44 with a remainder of 4.
Okay, so you get the 44.57 in your calculator, so you put the 44 here, and then the 44 times 7 is 308. So we have 44 multiples of 7 we can take out of the 312, and when we subtract it away, that's where you got the 4. Okay, great. And then I think you had an example of a check digit. So does someone else in your group have that written down? That was on your folder, wasn't it? Okay, so you could just read us the number, okay?
84410.
Don't give us the check digit.
603164.
Okay, and we have to find the check digit. Okay. So the pattern was to multiply by 3 times 1 times 3 times 1. So that pattern you'll need to know. You don't need to know the one for checks. And then you'll have to find a check digit. So on your 3x5 card, that might be something you put down. Times 3 times 1 times 3 times 1. Or maybe you'll just remember. Did you add these up then?
Yeah.
What did it come out to?
71.
71. So what does that mean your check digit must be? 9. Good. 9. So there's a 9 there, because 71 plus 9 is 80, and you have to get to a multiple of 10. So 80 is equivalent to 0 mod 10. So the check digit needs to be a 9, so you can get up to that multiple of 10. Yes?
What about the check digits in front of all the numbers?
Like when you're trying to find this number missing? I won't give you one like that. That's kind of hard, and we're doing a quiz. We're not, yeah.
I think on the Wiley Plus math, it was asking for like the checksum of each three, and then it was saying like what one was correct. And I could find the one that was correct, but I did not know what answer it wanted me to put in those boxes. It was so weird.
This number is called the checksum.
Okay.
So you probably can still get partial credit if you go fill in this whole total.
Right.
The whole total, okay. On the quiz though, you'll just have to find that last digit on the end, the 9 or whatever the number is. Well, your group also had, oh no, that's a new group. Okay, thank you. Okay, where's the 2.6 group? 2.6, okay. You had to prove that a particular square root is irrational. We don't have time to look at that. Maybe we will later, and if we do, we'll come back. But this also, I refer you to in the video, because it takes a long time, but it's worth lots of points. So if we have time to come back and look at one, we will. As you're doing that, when you put it on your 3x5 card, you'll use a particular root, like maybe you're proving the square root of 2 is irrational. Your quiz will probably not have the same square root you put on your card. So don't keep writing the same number down that's on your card when you're trying to prove a different root is irrational. Write the new root down for full credit. Were you able to figure out what I was talking about here? What does it mean? It means that for the rational numbers to be dense means that there's another rational number between any two given rational numbers. So if I give you a rational number here, and a rational number that's a little bigger here. So I have 2.413, one rational number, and another rational number, 2.414. Can you come up with one in between? So we need to be at least as big as this one. So we have to start out with the 2.413. But I need to get a little bigger, right? So just put anything you want after that, and it'll get bigger than the 2.413. It'll be a tiny bit more added on. But it still won't be as big as the 2.414, because in the third decimal place, that 4 is bigger than the 3 in the third decimal place. So that's how you can get a number in between like that. And you can do that as often as you want. You could put 2.413, anything that's not 0. So there's an infinite number of numbers in between 2.413 and 2.414. That's why we say these numbers, these are dense, they're thick. Mindscapes 10 and 12 are opportunities to prove that a square root is rational, right? Did you get a chance to look those up? That's what those are. So more of these. Okay, that brings us to, thank you. That brings us to the 2.7 group. Were you able to describe the decimal expansion of rational and irrational numbers? Okay, what can we say? We'll split this up here. How does the decimal expansion of rational numbers look?
For rational, it repeats on the right and it terminates.
So repeats on the right or terminates, one of those. So decimal expansion just ends like it does with the 2.413, just ends. Or it could repeat on the right. It could be 2.41333333. Going on forever. How about the decimal expansion for irrational numbers?
It doesn't terminate or it doesn't repeat.
Doesn't terminate. Doesn't repeat. Great. So I'll give you a list of numbers and you can tell me whether they are rational or irrational. And the whole class can do this, okay? So here's a list. 0, 1, 0.5, 2.3, 4, 5, 6, 7, 8, 9, 10, 11, 12, ... Negative 3.12222, ... Square root of 5, comma, 3/5. So go ahead and circle in that list, circle which are rational. Go through that list as a class here, each one of you. Circle the ones that are rational. Should we circle 0? If you're not sure, use your calculator, okay? Can you put 0 as a fraction? Remember, rational numbers can be written as fractions. Can you write 0 as a fraction? Yeah. 0 divided by 6 is just 0. So, yes. How about 1? Yep, good. 0.5? Yep. How about 2.3, 4, 5, 6, 7, 8? No, good. How about the negative 3.1222? Repeating? Yep, because that pattern on the end just keeps repeating. Square root of 5? Yeah. That one's irrational. That's one of the things that we proved in section 2.6. Prove a particular square root is irrational, and that would be one of those. How about 3/5? Yeah, that one is, right? It's written as a fraction already. So these mindscapes, 20 to 24, did you get a chance to look those up? Oh, yes.
I'm sorry.
No, that's okay.
I'm just confused. Why does the 2.345, why is that one not rational?
Because this pattern does continue, and it is a pattern, because you know what's coming next, right? 1, 3. But it's not a repeating pattern. It doesn't say 1, 2, 1, 2, 1, 2. Okay. I'm glad you asked. Any other questions? Did you get a chance to look up these 2.7 group? Oh. I believe they're to rewrite a rational number which is in decimal form as a fraction of integers. So let's just do that. Let's do that with the Negative 3.122 repeating. So let's write negative 3.122 repeating as a fraction of integers. We went through and figured out a strategy for this. Does anyone remember the first step? Yes.
Where we find where it stops like repeating. So you go like, you go 3 over. Yeah.
So you're thinking you multiply by a power of 10? Maybe that's the step you're thinking of. Pardon? Name it n. Okay, name it n. Is that what you said? Okay, name it n. So we give it a name. And then we're going to multiply by a power of 10. Either 10 or 100 or 1,000 or 10,000 or 100,000. How do we know what power of 10 to multiply by?
So many numbers are repeating.
Good. How many numbers are repeating? How many numbers are repeating? Yeah, just one. The number 2 is repeating. Two is repeating. Just one digit. Multiply by 10. 1, 0. So I'm going to say 10 times n, and then I move the decimal place 1 to the right. You can take out your calculator to do that if you want to, but remember you're not rounding off, so if you take out your calculator, let's just drop the minus sign, okay, and put the minus on at the end so that it doesn't get too confusing. I'm pretty sure I gave you a positive number on the quiz, so you don't have to worry about that. Okay, so multiplying by 10, and if you put it in your calculator, that's fine, but remember those dot, dot, dots go on forever. Don't round off. So you have your 10 times n. Now what do I do? Subtract. Yeah, subtract. That's right. Subtract the 1n from the 10n. And as you do that, you have to do what with the decimals? Line them up. Okay, so I'm going to, again, ignore the minus sign and line up the decimal. So decimal over decimal, 3.1222, dot, dot, dot. The reason that we line those up so carefully and that we picked the power of 10 we did so carefully is because now these numbers that are repeating should be over top of each other and should subtract away. So we get 10n minus 1n, that's 9n. And then all these 2's were over top of each other, so they subtract away. So you can take in your calculator and say 31.2 minus 3.1. I'm going to do that by hand. 28.1. We still have a decimal, so this problem has an extra step. This extra step is to do what? Yeah, multiply by 10 to get rid of that decimal. So multiply both sides of the equation by 10. We have 90n equals 281 then. Last step is to divide out the 90 from both sides of the equation. N is 281 divided by 90. And then you would check that. Okay, so what we did is we took the number, this is why I check. This was negative starting out. So negative 3.1222 repeating, and I wrote it as a fraction. So this should come out to negative 3.122 repeating in my calculator. And it does. So last, remember, you put a lot on your 3x5 card. Don't forget your 3x5 card. It won't be a fun day if you don't. Right. If for some reason you can't make the quiz here, let's see, this time is 11:40, right? Online students, you can come to either of these if you want to, or you folks also can come to the one that I'm giving at 8 and at 2:15. If for some reason you can't make it here, I'll have to email me and I'll email you the rooms then. I sent online students the rooms already, but I don't remember what they are. I'll see you on Wednesday. Thank you all for pitching in and helping.